Okay, folks, we're going to finish out chapter 4 with section 5 on isosceles and equilateral triangles. Now, I'm going to include a video for 4-6, but we won't be testing over it or anything. I'm just going to throw it in there just so you have it to look at, and just some important stuff that I'd like you to visit when you get a chance. Okay, but we'll talk about that then. All right. Now, homework quiz 4 or 5. Let's talk about how to prove that angle MJL, which is this angle that I'm going to show you right here, is congruent to angle KNL, which is that angle right there. But before we do that, we got to first prove that this yellow triangle right here is congruent to this triangle right there. Now, we are given that JM is congruent to NK and that L is the midpoint of both JN and KM. So we have those bits of information right there. So we could state that these are the given, as you know. Now, the next part says that L is the midpoint of both JN and KM, then that means it splits it and is the midpoint. So these two are congruent right there. And these two right here are also going to be congruent. And that is by definition a midpoint. Which basically right there is enough to prove that the triangles are congruent by side, side, side. Which then you can prove any remaining parts are congruent then by CP, CTC. All right. Now, like I said, I made it easier. I gave you the statements. Normally I don't do that, but with things going on, I gave you the statements. You just got to come up with the reasons. All right. Now, section 5, isosceles and equilateral triangles. All right. First of all, an isosceles triangle is any triangle that has two sides congruent. And the congruent sides are called the legs. So you got the legs right here, the two congruent sides. The third side is called the base. And the angles opposite the legs, and actually that should be legs there, so let me change that to legs, are called the base angles. So I have the base angles. Right there are my base angles. They're angles opposite the legs. And then finally, the angle opposite the base is called the vertex angle, and that's that angle right there, angle 1. All right, so angle 1 is the vertex angle. Angles 2 and 3 are the base angles. So highlight those right there in green. Okay, so you got all that. All right, now, here's what you need to know. Theorem 4.3, the isosceles triangle theorem, or ITT for short, says if two sides are congruent, then the angles opposite those sides are congruent. So in other words, since AC is congruent to BC, then that means that angle 2 is congruent to angle 1. So I got the sides pointed at the angles, saying that if the sides are congruent, then the angles are going to be congruent. Let me redraw that. I don't like that, so I'm going to fix it. That's kind of what we do. If you don't like something, you fix it. If you can't fix it, you live with it. But in this case, we can fix it. So there you go. Okay. So the isosceles triangle says if the two sides are congruent, two sides of a triangle are congruent, then the angles opposite those sides are congruent. All right. So that's that. Now, theorem 4.4 is the converse. I know some of you like to shoe the converse, but remember, converse means you flip it. So the converse of the isosceles triangle theorem says if two angles are congruent of a triangle are congruent, then the sides opposite those angles are congruent. So I'm going to flip this around this time, and this time I'm going to point from the angles to the sides. So the angles are congruent, then the sides opposite those angles are going to be congruent as well. All right, so Now, with that being said, excuse me. Theorem 4.5. If a line bisects the vertical angles of an isosceles triangle, then the line is also the perpendicular bisector. Okay, that's some important information. You can highlight that. If a line bisects the vertical vertex angles of an isosceles triangle, then the line is the perpendicular bisector of the base. All right, a corollary. A corollary is a statement that comes directly from a theorem. I used to joke that it's not a, well, never mind. I'm not going to go there. So, an equilateral triangle has 3 congruent sides and 3 congruent angles. So, that's what you need to know. All right. Now, corollary 4.3 says if a triangle is equilateral, it's equiangular. Corollary 4.4, if a triangle is equiangular, it's equilateral. So, all right. So, equilateral, it's equiangular. If a triangle is equiangular, it's equilateral. You don't have to need to remember those numbers. Just know that an equilateral triangle has 4 equal angles. And by the way, their measurement is 60. All right. Now, here we go. So let's get to practice of what you're going to see. Okay, you know that this is an isosceles triangle because there are 2 sides congruent. So isosceles, 2 equal sides. Okay, so we know that these 2 sides are congruent, which means that AC and, excuse me, I highlighted the wrong thing. CB are going to be congruent to one another. So I'm going to write that. I'm going to state that 4x minus 1 equals 2x plus 15. Subtract 2x. I'm doing some algebra right here. So I get 2x minus 1 equals 15. So therefore 2x equals 14. So therefore x equals 7. So x equals 7. Okay, now angle B and angle A, they're both congruent. So, because if it's in the isosceles triangle theorem, if 2 sides are congruent, the angles opposite them are congruent. So that means that 4y minus 26 equals 74. So you add 26, you get 4y equals 100. So therefore y equals 25. All right, we got that. All right. Let's do a few more so you can see how this works. Okay, now it says let's get some more practicing. We know that measure of angle M equals what we're looking for. We're also looking for PN. Okay, now we know this isn't the 2 angles are congruent. So that means that these 2 sides are congruent as well. So that means that if this is 11, then that is also going to be 11. So PN is 11. That's pretty straightforward. But we also know that since these 2 angles are congruent, then that means we need to figure out what number, if these both are the same, adds with 120 to give us 180. So let's come up with a variable. Let's call it x. So we'll call these both x since they're both the same. So I got x plus 120 equals 180. So I got 2x plus 120 equals 180. Subtract 120, you get 2x equals 60. So therefore x equals 30. There you go. So the measure of angle M equals 30 degrees. All right. Pretty short, simple, and to the point. All right, now, the same thing goes here. I know for y, both my y values are the same since it's isosceles, so I set 4y minus 2 equals 2y plus 2. You do the algebra, you get 2y equals 4, so y equals 2. Pretty straightforward. Now, okay, now this one, it's an isosceles triangle, so I know that these 2 sides are congruent, so I set them equal, I got y equals 2. Now, for the next one, I went ahead and I did the work for you. So I know all 3 angles add up to 180, but I also know that these 2 angles are congruent, so I add 6x plus 8 plus 6x plus 8, and add that to 80, get 180. And then I do the algebra, get 12x plus 96 equals 180, so 12x equals 84, which means that x equals, 7. not right. 84 there. There you go. It's a little bit better. All right. Now, I'm going to come back in a moment and we'll do the last one. Okay, let me show you what I've done so far. It's an equilateral triangle, so all three sides are congruent. So I set 23 equal to 3x minus y, and I set it equal to 2x plus y. And then from there, it's just algebra. Elimination, if you remember from algebra last year. So I got 46 equals 5x, because the y's cancel. So that means that x ends up equaling 9.2. All right, so, and then you could substitute it back in for either one of them. So I got 2 times 9.2 plus y equals 23, which ends up giving you approximately, well, we'll do the math here in just a moment. Okay, so, which as you can see, it gives us 4.6. I was making a mistake on my algebra, so I wanted to go back and make sure I didn't correct. Okay, now, for this last one, we know that all three angles are equal, but we know that their measurements are 60. So I set them equal. I said 2q plus r equals 60 and 3q minus r equals 60. So I do the exact same thing. This time I got 5q, because the r's cancel when I add them, equals 120. So when I do that, I got q, so q ends up equaling 24. And then I just plug it in either one. I just plug it in the first one. So 2 times 24 plus r equals 60. So 48 plus r equals 60. And then r, of course, is 12. So I got q equals 24 and r equals 12. All right. Just some algebra involved with that. And the big thing to remember is all three sides of an equilateral triangle are equal. All three angles are equal. And all three angles will equal 60 degrees since they're all the same. Okay, that was section 4.5. So go ahead and start working on HQ 4-5 for this Friday. And be prepared, as your test will be on the week of November 23rd and 24th, which is Thanksgiving week. So be prepared, unless things change.